Hello, y'all. Welcome to lesson 133 of my DP chemistry curriculum. Today we're going to cover structure 2.4.5, addition polymers formed by the breaking of a double bond in each monomer. Now, we're going to represent the repeating unit of an addition polymer given monomer structures, and we'll include polymerization reactions of alkenes. And you don't need to learn the structures of individual monomers. They will either be provided or you must deduce them. Now, in the last section, we talked about polymers. We talked mostly about synthetic, actually only about synthetic polymers. Synthetic polymers are ones that are made in a lab or by other means like that, but there are also things like natural polymers. Natural polymers, these are things that we see in nature. For one, in your body, all your macronutrients are generally examples of natural polymers. Things like cellulose in plants are natural polymers. Things like your proteins, your DNA, uh, things like complex carbs, which I mean cellulose is. Um, so these are all polymers. Even things like spider silk are all natural polymers. Now, the question is, though, how do we make these? So, how are these polymers formed? Well, for natural, if you're in a biology class, you may have learned about things like condensation reactions. Condensation reactions. Our body's ability to create polymers is one half of the metabolic processes we do. We either build molecules, which is creating these polymers, or we break molecules. So we do have a lot of natural ways to make these natural polymers. But today we're going to learn about how we make synthetic polymers, which is through what we call addition polymerization. Now, I use the American spelling with with a Z, but you can also use an S. Addition polymerization is exactly what it sounds like. To polymerize means to make, and addition, we are adding monomers together. In addition polymerization, what we're basically doing is we're breaking an alkene double bond, just like in electrophilic addition of alkenes, in monomers to form new bonds. But instead of forming bonds with like hydrogen or a halogen or a hydroxide, we're just forming bonds with the one next to it. So one of the best examples of polymerization can come from your kitchen in the form of Teflon. Teflon is also known as polytetra uh, fluoro. Oops, I put one U too many. Fluoroethene, uh, also abbreviated as PTFE. So that's Teflon. Now, if I just look at the word tetrafluoroethene, I know what that is. That actually tells us what our monomer is. Our monomer is an ethene, so C11C, with four fluorines, which means that our polymer is just that double bond broken and each one attached to each other. So now we can use that format we learned last time to describe n repeating units, which is how we draw polymers. And it just looks like this with our brackets n repeating times. So here's our Teflon or polytetrafluoroethene. And we can really just convert between one and the other by just changing this bond in the middle from a single bond to a double bond or double bond to a single bond. And this is why all of these are enes, because they come from the alkene monomer, because we need that double bond to break and form into the bonds that go to each other part of the chain. So with that, we can actually start predicting monomers from the polymer. So this is what you should be able to do in this unit. So if we look at some of the simple ones we talked about last time of maybe like the simplest one, polyethylene, polyethylene, which polyethylene is the IUPAC name, but you can always just use the commercial name, which is polyethylene. The commercial names add that YL, representing like an alcohol almost. And we know that our polymer for this is just carbon-carbon with their hydrogens. But we know the monomer is nothing but ethene. And so you should be able to do that. If we look back at polypropylene or polypropene, and I'll write both names, the DP may use one or the other, but they're the same thing. This time I will draw out the monomer, which is just propene. Oops. Simplify it here. You should be able to write the corresponding polymer notation. So go ahead, pause the video, try it yourself, and I'm going to do it right now. Start with my bracket, C, C, CH3, H, H, H. And that's it. That's our addition polymerization reactions. That's all you really need to know for the SL curriculum. For HL, we're going to go into a little bit more detail, specifically with with natural polymers in our next lesson. But otherwise, I hope this helps and have a great day.